Hi, my name is Devansh Singh. I built a question answering system for migraine. It is called MigraineAAT Knowledge Graph. It answers from the knowledge graph, not just from the memory. Every fact in the graph knows three things. The first one, whether it is true, not true, or only possible. The second one is how long it lasts. The third one is where it has come from. Today I will show you the problem, the system running, and the result showed. A patient sees a zigzag light for 20 minutes. Then a bad headache starts. The guideline says an aura lasts for 5 to 60 minutes. If a model answers about 3 hours, the patient stops worrying. But 3 hours is not an aura. It could be a stroke also. Three things cause this, and these are the three things I attack on. The first one, a medical graph has no slot for neglected facts. In vector space, denies fever and has fever sit almost top on each other. The second one, diagnostic criteria are defined by time, and a plain triples keep none of it. The third one is the handwritten queries, which breaks when you reverse the question, and plain vectors cannot follow a chain from a symptoms to disease and drugs. Each of these has been solved on its own. Assertion classifier exists built, but the output never reach graph edge. Temporal medical graph already exists, but edge carry no assertion. Biomedical graph network exists, but they predict links, not to the answers of the patient. Nobody has put all these three things together. And that is my gap. Nobody has measured which part actually earned its place. So I asked four questions, one per component and one commitment running through all of them. Prove it with controls, not claims. Here is my architecture diagram. I have taken three ICD-3 criteria, nice CG database, Hanitoid subgraph, and some synthetic timelines of patient. And then I built a new 4J graph of 4,974 edges, which has assertion, temporal, and source of edges. Then clinical bird is being trained onto it, basically extract the edges on a seven pointers, then pass it to the graph stage, which do the learn embeddings out of it. Then whenever the user questions comes in, it use those learned embedding, extract the nodes and fetch the data out of it. And then pass it those sources to the grok to generate answers. The answers are now cited with edge and the disclaimers. But one thing I would like to flag early here, I also built relational extractor over 43,680 PubMed abstract, and its precision is below 50%, so I have to throw those triples away. I reported them as a negative result. The bigger graph of backward claims is worse than a small one. This is a design decision. The whole project rests on. An ordinary medical graph is show one thing, this connected to that. Mine stores three modes: assertion, timing, and a source. The assertion and a timing become a seven number vector on the edge. Now the problem with the standard graph stage is when we pass a message between node, it mixes the neighbor together and ignores the edges. So I wrote down my own version. It is stick the edge vectors onto every message before mixing happen. Graph stage especially I have selected because it is inductive and because it let me do this. Transy or Planey wouldn't help me with this. Here, I have wrote a 75 fresh migraine sentences, which the system never sees, and my assertion classifier score 0.947, and my target was 0.73. So my research question is being satisfied over here. The second one is the on the right side, which is link prediction, reaches my AUC of 0.895. The embedding really did well in learning the shape of the graph. So here we have done the scoring of our processes. We have created a clinical reliability scores, which scores out of 0 to 12, and each of this section is given 0 to 3, where all cumulative become a 12. We ask a question: accuracy, did it reinvent the facts, evidence, and a safety. For the judging, we use a GPT-4o, a different AI provider, because we don't want to create a judging circularity. So to close that gap, we provide a open AI judging system also here. Here, if you see the migraine AAT, that the safety score is 2.88, accuracy is 1.3, and that is exactly why, because my system is refusing what it can't see, while the raw LLM is ahead because it's generating a fact which it don't know also. My retrieval beats both approaches, the naive approaches, RAG and normal graph, which gives me a consideration that the system is performing well in these things. On a 120 public question, I lose by 1.54, and that is a real loss. I reported it. The LLM has memorized a lot of headache guidance and answered smoothly. My graph has was under 5,000 edges, so it does not cover as much. When I retrieval miss, my system is refused to give the answer. But on the personal 30 questions, it flipped completely, plus 4.43. The size effect is 2.13, which is large, and you can see why in the dimension score. It it is not answering badly, but the system refuses correctly because it never see those record. Mine reads the timeline, applied the ICD-3 thresholds of 15 days a month, and cite the edge it used. Two controls, both designed to attack my own results. First, in is the personal win really a graph or just having a record at all? I gave a plain LLM the same record as an ordinary text with no graph. It scored 10.73 and I scored 10.57, too close to call. So the honest claim is that the win is access to the records, not the architecture. When the graph add on top is a traceable source, which rubric doesn't measure against what a real customer chatbot has, which is no record at all. The gap is still total. Second is the public loss caused by my prompt wordings. I ran the identical prompt with the retrieval facts taken out. Without them, it's like 11.44. With them, is 9.54. So the fact I retrieve are actively making worse. This is the most useful finding in the project. On the left, 2-hop returns 4,400 facts out of 4,900, like 90% of the graph every time. Why? Because 81% of the edge are the drug side effect from Hedinoid database. Every drug node connect to between 200 to 290 things, so the hop almost return everything. On the right, that explains the elevation. Removing edge features move the score by 0.02. Removing assertion label change 120 scores by exactly 0. Note that this elevation happened after retrieval, so it tests whether the generator reads the labels in prompt. It does not test whether the graph benefit from carrying it. Nothing survives the corrections, and the one significant result returned back. The plain similarity beats my learned embedding by 0.46, but the model did not fail to learn. It reached a AUC of 0.895, and it cannot help when the retrieval hands over the whole graph, regardless of ranking. And this matched the same study by Shane and colleague in 2025 on the knowledge redundancy in medical RAG. The fix is sparser retrieval first, then a much larger graph. Conclusion. Out of my four research question one is yes. Research question two is partially because right direction, but it masks my retrieval saturation. Research question three is also yes because it beats the RAG and the cipher. Research question four, it's basically access, yes, because win on timeline, but beat on the architecture. My limitations are I'm using a single LLM judge, self-authored benchmarks, and a graph is too small and three synthetic timelines. The system answers the timeline question on ungrounded model, cannot cite the clinical source behind every answer, and my system absent instant of fabricating the responses. At this graph scale, through the retrieve subgraph act as a distractor on a public questions. So here is the demo of my application. As the page loads, we land onto this page and we can see the chat screen over here. We have a two modes here, public and personal, with the sub modes of hybrid and strict knowledge graph. So right now we do a testing on a public with a hybrid mode. We ask a question, does migraine cause fever? So we receive the answer that no, fever is absent as symptoms of a migraine without aura during the headache phase. And also we got a warning here so that we make a safe AI usage for the medical queries. Onto the right, we can see the retrieve serve graph which is basically in the teal color nodes, and we can hover onto them and click and see over to them. We can zoom in, zoom out, and we can see the connections also. Also, there is a retrieval rankings which are learned through the similarity, and here are the retrieval facts. Now let's ask another question also. Let's say we go, how many headache days per month define chronic migraine? Here we receive the answer, and it's like chronic migraine is defined by headache on greater than 15 days a month or for 3 months. And for that, we got a retrieve subgraph with the symptoms and its connected nodes. Here is the retrieval ranking for the learned similarities. The same way, let's go with another questions also. Here again, we receive the answer. When a headache a medical emergency. So we receive our answer with the retrieval subgraph and its ranked similarities. Now let's move to the like the personal mode where we can ask a question onto the patient data. We have a three patient data, Alice, Brian, Carol, and we can ask a question. We will select the patient over here and ask a question onto it. Here, we got our answer that based on to the users and the patient information, we received the answer. Your latest report of this show the headache. Also, our system is outperformed onto the personal information of the patient because we have a track of it. But onto the public data, our system is failing a bit because our knowledge graph is limited to the 5,000 nodes only. So the extension of the knowledge graph is required to make our system more better in terms of the responses. But the best part, this system outperformed the normal RAG and normal graph models. It's achieving a similarity scores according to the raw LLM, even though it absents and don't answer sometime when it don't have the records. Here from the benchmark page, user can compare LLM, vector RAG, graph cipher, full system. If you see the vector RAG and graph cipher, we already outperformed the system. Just the thing is, raw LLM already has a vast knowledge of headaches and migraine, so it's hard to compare with the 5,000 nodes. Then we have this graph section from where user can see the knowledge graph of the migraine. We can zoom in, zoom out on this and see the nodes connected to each other. Another section is albation, where the albation study is visible here. And at last, the about section where the architecture of the whole application is there. Thank you so much for your time. I'm open for the questions. Thank you.